Hello everyone and welcome back to Whitehorn Racing. Today we'll talk, as often happens when I'm talking, of ancient things. We will deal briefly with cooling systems on cars and in particular with discontinued cars. Today, for a change, let's talk about cooling systems. In this case, cars, but it is clear that liquid-cooled motorcycles also use the same system. So we'll show you roughly how it worked and some differences. So we don't have much material right now. There are two examples of old car radiators. This is a radiator from a Fiat 127, from a car that was from the 76. The fan is similar to the one originally fitted, but I had to change it. This 127 was my car, so this is an early 2000 fan, but it was a leftover. You see, it says Fiat 127. Instead, this is a much more noble radiator, much more noble than it was on my father's Alfa 2000 sedan Giulia Mechanics. This is the back, the part facing the engine. In fact, you see that there are two unions. The hot water comes out of the head, enters here, and then comes out cold after having crossed the vertical pipes. And this is the front. Now, it has been scratched when we disassembled it. It got a little damaged, but it doesn't matter. However, liquid cooling is always better than air cooling, because the ability to dissipate heat is much better, and it prevents the formation of hot spots much more easily, because a thick liquid removes it. Beware that water, contrary to what one might think, is a very bad conductor of heat. It removes heat only because it passes through colder surfaces in the form of a thin veil, such as those of the radiator, on warmer surfaces such as those along which it flows in the head. And then there is continued exchange, because the particles don't have the same position but constantly change position in the flow. It's true that ice is an excellent insulator, so water has this characteristic. It has a very high specific heat. In fact, even if the manufacturers rightly recommend mixing the water with various antifreeze, which then normally based on ethylene glycol, the higher the percentage of ethylene glycol in the water is, the lower the ability to remove heat for the same mass per second. The liquid cooling used in the vast majority of cars, we remember the noble exception of the Porsche until not many years ago, but it had a particular engine block. Well, it has great advantages over air cooling, because it prevents the formation of hot areas, and the amount of heat that can be removed is in any case greater in the end. And in fact, the liquid removes the heat everywhere, and it is more difficult for areas to form, because maybe the air doesn't pass through or doesn't reach it well, and they overheat a lot. And there's also another important factor. In air-cooled engines, you have to be very careful of small oil oozes, because they create the formation of sludge, because the fan that blows the air pushes the air together with dust, and the oozes of oil cause more and more consistent sludge to form, which occludes the things which result with results you can imagine. Briefly, the difference between these radiators: that radiator there, although oversized, was born for a 45 horsepower small engine. This radiator here was on an Alfa 2000 with 132 horsepower. The difference is in size, but it's not that big. However, the material changes. This is a copper radiator. This here is a radiator that has the cap on the top and the cap on the bottom made of brass, the pipes of brass. But blades are of ferrous sheet metal because the magnet sticks to them. This other one instead, I don't know if you see some pink here, this is all copper, so the ability to dissipate the heat is completely different. The electric fans in the most modern system between these two that we are observing are used for driving at very low speed in the city, in the stop and go of the traffic, but clearly being the cooling entrusted to a motor that can have like 50, 100 watts depending on the vehicle model. Some powerful super sport cars of the 70s had two side by side on a very wide radiator, double or triple this. Obviously, it's not even conceivable that a full power motor sees enough airflow generated by two such fans, which rotate with the power of such a small motor. The airflow that hits the radiator from the front is always more efficient, even when driving uphill. Clearly, some tests were probably being done, but for sure keeping the engine in prime at 30 per hour or 40 per hour at full power on a 35% climb would surely have meant boiling the water, surely, on a vehicle cooled with an electric fan system. And the fact is that it doesn't happen in practical use. We come into another detail. Even the motorcycles, modern motorcycles in particular, the powerful ones, are all liquid cooled. The motorcycle radiators are very efficient and are of excellent quality. They are not large because apart from the quality, the air is conveyed by the fairing, which causes the radiator to be hit by a constant and intense flow of air at high speed and well directed. It must also be said that powerful motorcycles are missiles, such that the power of the engine is fully exploited, or in any case it's insignificant percentages, only when the vehicle is launched at 180, 200, 230, 300 per hour, but at low speeds, the airflow becomes scarce. And when standing still, when in traffic, for example, there is that fan that on the bikes is much smaller than this. Sometimes they have two, but in short, that's what it is. I can tell you that from my experience, I had both a VFR 800 and a Honda VTR 1000. The temperature, especially on the VTR running at 70-80, was close to 100 degrees. Going to 150, 160, it dropped to 82, 78 degrees. This is to tell you that about the efficiency of the fairing. And here we come to a particular question. When you burn out, or in short, do stunts of the kind, you keep the engine revved up. You force it to deliver a certain power, not the maximum, but still a good handful of horses, turning in round at 0 speed. If you insist until the tire burns, as you can see done in many videos, it's clear that the fan will never be able to remove the heat generated. Don't burn out. Now, of course, on no car is there any more radiator with the fan always pulled by the engine. Before it was very widespread, but now it's no longer used, even rightly so. All have either electric fans or, better still, more expensive cars have fans that have a viscous trigger or an electromagnet that attaches them and makes them pull from the engine when needed. They're all great systems. It must be said that the electric fans on the cars of the 70s were sources of countless problems because the scooters were out and didn't work. They tended to break. The collector were out, the brushes were out. At a certain point, the fan wouldn't start, the machine heated up, or the thermal contact that triggered it didn't work. In short, that's how it was back then. As you know, on liquid-cooled 4-stroke engines, there are two liquids. There is water and there's oil. Now, the water, also by virtue of the fact that there has always been a thermostat, heats up earlier, and heats up even when the climate is harsh and even when traveling relatively short distances. Oil, on the other hand, doesn't, because if the vehicle drives at low speeds, especially if it is a powerful vehicle and therefore has an oversized, well-finned tank as the Alfa Romeos were in the past, especially on a Giulia mechanical basis, which had the tank of more or less equal capacity than that of the Alfetta but mounted sideways, therefore more exposed to the airflow. Even more so if they have oil radiators with thermostat, they have difficulty in getting the oil reach temperature. And this is very dangerous, especially if it happens repeatedly. There is an engine used for short distances that has a lot of oil in the tank, and above all with a very thin sump, and then those oil never reaches the operating temperature, therefore from 90 degrees upwards up to 120, 130, especially with modern oils, they can wear out very quickly because the oil ends up not reaching all the points that need lubrication, and it's a problem. Then for some time, and now it's also quite widespread, they have brought out a wonderful egg of Columbus, which is the water oil exchanger, for which there is no need for the air or for the oil cooler. There is no need for the relative thermostat, but the task of cooling and heating of the oil is carried out by the water cooling system, which is perhaps a little bigger than a radiator. But this exchanger, which is a small object, and now I have none here because in part it's comparative in the crankcase. Many vehicles have it, even Fiat JTD engines have it. It's an object that is more or less incorporated into the engine, in which water and oil circulate together, separated by a coil, so that the water can release or remove heat from the oil. And so, what happens? That when the engine is recently started, the water immediately reaches temperature and hits the oil. It immediately brings it to 70-80 degrees. Then, if the path becomes long and high performance is required, for which the oil tends to heat up a lot, at that point it's the oil that transfers heat to water, so it always remains at the optimal operating temperature. Although the speech was very short, I give you one last little notion. You have seen that these two radiators have this other spout. This here is the spout of a tube that leads to the so-called expansion tank, which is also present on many cars now, but back then its system was more rudimentary. However, there was a cap that had two gaskets, the lower one with a spring and the upper one with a seal. This one below has two seals in the radiator. This one below the spring is in the middle that allows the springing, and that one above, which is precisely the closure. So what happens? When the temperature rises and there is an increase in volume, or little gas should form, which is better not to happen, but also in the event of any damage to the head gasket that puts too much pressure on the system. This event of any damage to the head gasket that puts too much pressure on the system, this spring yields and allows passage of the water itself, which increases volume towards the expansion vessel, which is connected to the end of the tube. Then if, on the other hand, when the water withdraws, because everything cools, it's sucked and re-enters the radiator. The expansion tank is used for this, and is also used when there are bubbles in the circuit, so that the circuit finishes purging it in a certain time. So the air is expelled in this way, and then the liquid is sucked in again when the engine stops. If you liked this video, leave a thumbs up and share it with your friends. Remember, White One Racing is not a workshop, but an amateur sport association that works on engines only for sport purposes and only for its associates.